Thank you. In 1898, Sir William Crookes was his last name. He was a famed scientist who was elected the president of the British Association for the Advancement of Sciences. And in his famed inaugural address, he spoke of the 19th century farmer with gloom, how they tried to increase their crop yields year over year and faced decreasing crop yields. And he talked about how we needed a source of fertilizer, essentially a natural source of fertilizer that can help farmers of the future increase their yield. And there was a decreasing amount of natural sources of fertilizer available. He talked about in 30 to 40 years, he predicted that there would be famine faced by what he called wheat-eating peoples if this problem couldn't be solved. So he looked at the room of scientists and innovators and he asked them to do the impossible, to leverage the nitrogen that surrounds us in the air that we breathe, to pull nitrogen out of the air to make fertilizer. So with that, the race was on, and scientists, innovators were working diligently to try to come up with a way to pull fertilizer out of the air. And lots of innovation happened, technologies were born, companies started, but ultimately it was Fritz Haber who was able to figure out on a tabletop how to turn nitrogen, pull it out of the air, and turn it into a fertilizer. And in 1918, he was awarded the Nobel Prize for this invention. And it was Carl Bosch who ultimately figured out how to scale that to bring fertilizer to farms of the world and to the masses. And this invention, called the Haber-Bosch process, is actually thought to be one of the most important inventions of humankind. And that's because it is believed that it would take 4 times the amount of land that we use today to feed all of us, to create the food that we create today, 4 times. Also, it is estimated that 50% of the nitrogen that's in human tissue comes from the Haber-Bosch process. So this was a hugely instrumental advancement in society. So fast forward to now. Now we have a new problem that we have to face when it comes to feeding the nations. And the problem is that we're running out of food. And it's when Sir William Crookes gave his speech, Crookes, I keep missing that S, but when he gave his speech, there was about 1.6 billion people on the planet in 1900. And so the population has since exploded. According to the United Nations, today we have 8 billion people on the planet. Today is the day that we've crossed over, and now there's 8 billion people on the planet. That's a huge explosion of people over that time. And in the process, the way that we make food today has depleted our natural resources. There's been an amount of land cleared that's equivalent to the size of South America and Africa combined to make room for the way that we make food today, whether it's grazing or feed production for animals, or directly for us. And rainforests have been cleared drastically in order to make room for this. In addition, the current way that we make food contributes more greenhouse gases to the environment than the entire transportation sector. And to double click on that, one area where you can see this problem is how we make a steak. So I'm going to talk about it in a way that you're not used to. But the technology that we use to make a steak is very similar to the technology that we used back when Sir William Crookes gave his speech, and it's a cow. It has the greenhouse gas footprint of a car, and it takes 2 years to make a steak. So that's 2 years. That's hugely inefficient. It is consuming that whole time water and grass and feed, and very small percentage of the nutrients that go in actually end up in the product. The meantime, in addition to it having the greenhouse gas footprint of a car, it is one of the leading causes of deforestation. So we need new options. And we need new options because it's estimated that there will be 10 billion people on the planet, and so where are we going to get all this land from? And how do we grow food in a way that doesn't break the planet? How do we grow food in a way that doesn't have a negative impact on the climate, that doesn't remove all of our rainforests, and doesn't deplete our oceans? Is a challenge that we have in front of us today as our population continues to grow. So we need a revolution in food. It is just simply required. So 100 years ago, when there was a food challenge, the question was, can we pull nitrogen out of the air and make fertilizer? Today, one might ask, can we take elements of the air and just make food directly? Can we just skip that step? So in order to ask this question, you have to think outside the box. And in our case, we think outside the planet. If you're looking at going to space or a distant planet, you have to figure out how to grow food in a very different way. You have to figure out how to grow food in a way that doesn't require lots of resources and uses a minimal land footprint or minimal space, and can grow quickly, essentially. So in the 60s and 70s, the scientists at NASA were looking at this particular problem. And they had lots of ideas, lots of innovations that they came up with. But the space program ended, and the ideas were simply sitting on the shelf. So we looked at some of their great ideas and began working on a way to use cultures and simply air, water, and energy to make food. And the process itself is called fermentation, but it's a specific type of fermentation, which we call elemental fermentation. Fermentation is how we make our cheese, our wine, our yogurt, and our beer. But this is a different type of fermentation where you use elements of the air, water, and energy as your key ingredients, in addition to some elemental nutrients. And from that, we can make food from air. This way of making food from air requires no arable land whatsoever. So you can think about it as the next generation of vertical farming. It's landless agriculture. And it doesn't require any inputs from agricultural. It doesn't require any inputs from animals. So traditional fermentation will need milk or a source of carbohydrates, and this just needs elements of the air, water, and energy. And the process itself happens to be the most sustainable way to make protein or oils or carbohydrates on the planet, from a land utilization standpoint, from water utilization standpoint, and then from a carbon intensity standpoint. It's actually carbon negative. So as we've built this food system that we have today, industrial farmers, factory farmers are battling diseases, animal diseases. They're battling insects and trying to have hyper growth of animals. And so that leads to an industry that has a lot of hormones, antibiotics, herbicides, pesticides. And this process is free from all that. So what we're making today and scaling up is a way of making protein directly from elements of the air first. And this protein ingredient that we're able to make, this flour, it is rich in all the essential amino acids. It's a complete protein. It is rich in vitamins and minerals, and it's very nutritious, highly digestible, and very nutritious. And once you have a protein, you can do many things with it. Once you have these elemental ingredients, you can create many different foods. The opportunities are endless. And why not start with meat? Why not start with that biggest culprit when it comes to the environmental impacts? So in 2019, we made the world's first air-based meat, the first meat made from elemental fermentation. And we've gone beyond that. We're making everything from things that are similar to chicken, like our chicken fillet, something that's similar to a scallop, seafood, beef, pork, and beyond. The way that we define meat is that experience when you have that product on the plate, and not the fact that it took 2 years to get there. So we're making a new way of making the great textures and the flavors that you're used to when you bite into a juicy steak or a chicken breast. With this, the impact that we seek to have, one of the impacts, in addition to land and beyond, is to avoid 1.5 million tons of CO2 in the next decade. That's what we're looking to do with this technology. And so as I wrap up, what presentation is complete without a picture of pretty babies? As the marketing people will tell us. But seriously though, as we think about our children and when they're our age, and we think of our grandchildren and when they're our age, what kind of planet are we leaving them? So the time is now for us to really get serious about thinking outside the box and fearlessly creating new opportunities for tomorrow. Thank you so much.